Okay, let's go. Number 1. Black hole cosmogenesis. You are standing on the surface of the Earth, and right now, according to a small but serious group of physicists, you are also somewhere else. You are inside a black hole. Not metaphorically. Not as a thought experiment you can shrug off after the video ends. As a literal description of where the universe you're living in came from and what it currently is. In 2010, physicist Mikołaj Poplawski, then at Indiana University, published a paper that took a known problem in general relativity and solved it in the least comfortable way possible. Standard physics says that anything falling into a black hole gets crushed into a singularity, a point of infinite density where the equations simply stop working. Poplawski added torsion, a twisting property of spacetime tied to the spin of matter, into the gravitational equations. With torsion included, the collapse doesn't end in infinite density. It reaches a maximum, and then it bounces. On the other side of that bounce is a new, rapidly expanding region of spacetime. From inside the collapsing star, it looks like annihilation. From the other side, it looks like a big bang. Every black hole, in this model, is a seed. Cross the event horizon of any black hole anywhere in the universe, and past the point of no return, spacetime doesn't end, it turns inside out and starts expanding again, sealed off from the parent universe that made it, permanently disconnected, running on its own clock. Physicist Lee Smolin took the implication further. If every black hole spawns a new universe, and if the physical constants of each new universe drift slightly from its parents, the way a mutation drifts from a parent species, then universes that happen to produce more black holes will produce more offspring. Run that process over unfathomable spans of metatime, and you get a form of cosmological natural selection, universes evolving generation after generation, toward maximizing the one thing that lets them reproduce. Black hole production. Here's where it gets strange. We have photographs of this process starting. The Event Horizon Telescope has imaged the shadow of the supermassive black hole at the center of galaxy M87, roughly 55 million light-years away, and the black hole at the center of our own galaxy, Sagittarius A star, a scant 27,000 light-years from where you're sitting right now. If Poplawski and Smolin are right, both of those images are baby pictures. Something is happening past those event horizons right now, sealed away from us forever, that looks, from the inside, exactly like the birth we ourselves already went through roughly 13.8 billion years ago. Nobody outside a black hole can verify what happens inside one. That is not a limitation of current instruments, not a problem better telescopes will eventually solve. It is a mathematical property of the event horizon itself, a one-way membrane, a boundary that admits everything and returns nothing, not light, not radio waves, not data of any kind. Whatever is being born in there will never send us a signal. It will simply exist, complete, sealed, running on a clock that no longer shares a single second with ours. So if this is where we came from, that means somewhere, in some other universe entirely, obeying laws we cannot access from here. There is a collapsing star, an event horizon, an apparent reality that will never know what it made. If our universe was born this way, we are already, right now, sealed inside the answer, wearing it as home. And if the boundary between one universe and the next can be crossed once, in one direction, the next theory asks whether it might be crossed twice, in two directions at once, by a version of everything that is somehow already here. Number 2. The CPT symmetric universe. You are looking at a single point, the moment of the Big Bang, and you are being asked to consider that it is not a beginning. It is a mirror. And standing on the other side of that mirror, right now, running in the opposite direction, is a whole universe made of antimatter that is, in a very specific mathematical sense, also you. In 2018, physicists Latham Boyle and Neil Turok, working out of the Perimeter Institute for Theoretical Physics, published a proposal built on one of the most sacred rules in physics. CPT symmetry. Charge, parity, time. Flip all three at once, and the laws of physics should look identical. Boyle and Turok asked what happens if you take that rule and apply it to the universe as a whole, at the single instant of the Big Bang. Their answer, the universe on our side of the bang, expanding forward through time, filled with matter, and a second universe on the other side, expanding in what looks to us like the reverse time direction, filled with antimatter, moving away from the same central point. Not a separate creation, not a parallel universe branching off somewhere else. The same event, viewed from both directions at once, like a single object, and its reflection sharing one mirror instead of existing as two things. The proposal isn't decoration. It does real work. A universe plus its CPT mirror twin has exactly zero net quantum numbers. Exactly the simplicity you'd expect from a system that didn't need anything outside itself to explain its own existence. And it makes a specific, testable prediction. Right-handed neutrinos, sterile to every force except gravity, could be exactly what we've been calling dark matter, produced in the correct quantity to match what telescopes already measure across the sky. Here's where it gets strange. In this model, before the Big Bang isn't a question that reaches backward into empty time. It reaches sideways, into a universe running the opposite way, where, from that universe's own internal perspective, its arrow of time points away from the Bang too. Both universes call themselves the present. Both call the other side the past. Neither is wrong, because in this geometry, the labels before and after were never fixed in one direction to begin with. They were assigned locally, by whichever side of the mirror you happen to be standing on. Nobody has detected the mirror universe directly, and by definition, in most versions of this model, nobody ever fully will. It sits on the far side of a boundary condition, not a distance. You cannot travel to it. You can only calculate that it must be there, the way you calculate the existence of the far side of a mirror without stepping through the glass. If a whole universe can exist as a mathematical requirement, invisible, unreachable, entangled with our own only at a single infinitely thin seam, then the real terror isn't the mirror universe. It's the possibility that reality routinely contains entire completed structures we will never observe, only infer. And the next theory takes that possibility and turns it on the one thing you were sure you could trust without inference: your own memory of a past at all. Number 3. The Boltzmann brain problem. You remember breakfast. You remember years of birthdays, arguments, a childhood bedroom, the specific sound of a door in a house you grew up in. You are completely certain a past happened to produce you. Here is the problem. According to a well-published piece of cosmological math, a fully formed brain, complete with every one of those memories, false and detailed and internally consistent, is overwhelmingly more likely to simply fluctuate into existence out of empty quantum vacuum than an entire 13.8 billion-year-old universe is to have actually happened. The physicist Ludwig Boltzmann noticed the seed of this problem in the 19th century while trying to explain why the universe has any order in it at all, in a cosmos governed by entropy, which always increases. If you wait long enough in a large enough universe, random thermal fluctuations should eventually produce pockets of low entropy, pockets of order, purely by chance. Modern cosmologists, including Andreas Albrecht, Lorenzo Sorbo, and Sean Carroll, picked the problem back up in the context of eternal or near-eternal cosmic inflation, and ran the numbers all the way through. The math is not close. Producing a single self-aware brain, floating alone in the vacuum, with a complete but entirely fabricated set of memories already installed, requires an almost unthinkably smaller fluctuation than producing an entire ordered galaxy full of real stars, real planets, and billions of years of real observers, accumulating real pasts. Entropy makes order expensive. A whole universe's worth of order is staggeringly more expensive than one brain's worth. If the universe lasts long enough, and current inflationary models suggest it might last for an effectively unbounded stretch of time, these spontaneous brains, cosmologists actually call them Boltzmann brains, without irony, should outnumber real evolved observers by a margin that isn't close to fair. Infinity to 1, in some versions of the math, a ratio so lopsided it stops being a probability question and starts being an indictment of the model that produced it. Here's where it gets strange. This isn't a fringe thought experiment. It's treated as a serious defect, a measure problem, in some of the leading models of eternal inflation, serious enough that physicists have used it as a genuine argument against those models, on the reasoning that any theory predicting you're overwhelmingly more likely to be a fluctuating brain than a real observer has probably gone wrong somewhere. But notice what the argument requires you to assume in order to dismiss it. It requires you to assume you can trust your own sense that a coherent past occurred, that this sentence followed a previous one, which followed a childhood, which followed a birth. The Boltzmann brain problem doesn't ask you to consider a strange, far-off possibility. It asks you to notice that the confidence you're using to reject the idea is exactly the kind of confidence a fluctuating brain would also have, complete and detailed, and entirely unearned. Nobody has found a way to fully close this problem. It remains open, debated, unresolved in the technical literature right now. And if a single convincing brain can appear out of nothing, complete with a false but flawless past already installed, then maybe the real universe doesn't need an origin story either. Maybe it has already ended, and restarted, and ended again, more times than there are atoms to count them with, and what you're calling now is simply the most recent flicker. Number 4. Conformal cyclic cosmology. You are looking at the oldest light that exists, the cosmic microwave background, the faint afterglow left over from 380,000 years after the Big Bang, mapped across the entire sky by satellites in exquisite detail. And a Nobel laureate is asking you to look again, because he believes there are circular bruises in that light, and he believes he knows what left them. Sir Roger Penrose, who shared the 2020 Nobel Prize in Physics for his work on black holes, has spent years developing a theory called conformal cyclic cosmology. The proposal is direct. Our Big Bang was not the beginning of everything. It was the rescaled remnant of the end of a previous universe, what Penrose calls an eon, and that eon will not be the last. Here is the mechanism. As a universe ages, its expansion accelerates, matter thins out, and eventually, after an unimaginable span of time, everything left in it is either massless or moving close enough to the speed of light to behave as if it were. At that point, the mathematics describing its geometry, called conformal geometry, stops distinguishing between something infinitely large and something infinitesimally small, the way stretching a rubber grid out to infinity and shrinking it down to a point can, under the right transformation, describe the exact same shape. An infinitely stretched out, radiation-only universe becomes, in the equations, indistinguishable from a single infinitely dense point. Penrose's claim is that this isn't just a mathematical coincidence. It's a literal seam where the dying end of one eon becomes the fresh, hot beginning of the next, over and over, without any actual first beginning at all, going back forever. Working with astrophysicist Vaha Gurzadian, Penrose searched the cosmic microwave background for a specific fingerprint, concentric rings of unusually uniform temperature, which he argued were the radiation footprint of supermassive black holes evaporating at the very end of the previous eon, then getting stretched and rescaled into our own sky. He named them Hawking points, after his late friend and collaborator Stephen Hawking, whose own work on black hole evaporation made the prediction possible in the first place. Here's where it gets strange, and where honesty requires a pause. This claim is genuinely contested. Penrose and Gurzadian published their detection in 2018 and again in 2020. Other cosmologists, including researchers working with data from the Planck satellite, have reanalyzed the same maps and argued the ring patterns aren't statistically significant, that they're consistent with ordinary random noise once you account for how many places you're allowed to look. The debate is active. It has not been settled either way, but consider what's actually being argued about. Not whether the cosmic microwave background exists, everyone agrees it does. The argument is over whether specific visible marks in that oldest light are the literal, physical scar tissue of black holes that evaporated in a universe that existed and ended before our own began. Even the skeptics aren't disputing that the previous eon hypothesis is coherent. They're disputing whether we've found the fingerprint yet. If Penrose is right, we're not looking at the beginning of everything when we look at that ancient light. We're looking at a crime scene. And if the scars from the previous eon really are sitting in our sky, unconfirmed but not disproven, then the next question is whether that boundary between one universe and the next was actually as smooth as the mathematics assumes, or whether something violent happened at the seam, something with enough force to leave more than just scars. Number 5. Loop quantum cosmology. You are running the equations of quantum gravity backward toward the Big Bang, expecting them to do what general relativity always says they should do: collapse everything into a singularity, a point of infinite density where physics gives up. Instead, at a certain density, the singularity simply refuses to form. The math hits a wall, stops, and pushes back the other way. This is loop quantum cosmology, a serious subfield of quantum gravity research developed by physicists including Abhay Ashtekar, Martin Bojuald, and Carlo Rovelli, largely centered around Ashtekar's work at Penn State's Institute for Gravitation and the Cosmos. Loop quantum gravity starts from the premise that space-time itself isn't smooth and infinitely divisible. It's quantized, built from finite units of area and volume, the way matter is built from atoms instead of being infinitely divisible mud. If space itself comes in indivisible chunks, then density can never actually become infinite. There's a floor, a smallest possible volume that anything can be squeezed into. As a collapsing universe approaches that floor, packing more and more matter into less and less space, the granular, quantized structure of spacetime itself starts to push back, a repulsive quantum gravitational effect that has no equivalent anywhere in ordinary, classical physics. Instead of crushing down to a point of infinite density, the collapse simply runs out of room to continue, halts, and reverses. Contraction becomes expansion, in an instant, at a density far short of infinite. The Big Bang in this model is not a beginning. It's a bounce, the visible aftermath of a previous universe that contracted down to an almost unimaginable, but strictly finite, density and rebounded into the universe we're standing in now. Here's where it gets strange. A bounce this abrupt shouldn't necessarily erase everything that came before it. Some structure from the contracting phase could, in principle, survive the transition, the way a tightly compressed spring still carries information about its shape before you squeezed it. Researchers working in this area have proposed that specific anomalies already observed in the cosmic microwave background, unexpectedly low power at the largest angular scales, patterns that don't match a smooth, mindlessly random inflationary beginning, could be exactly this kind of survival. Not noise. Memory. A gravitational echo, carried physically across the bounce, from a universe that existed, collapsed, and pushed through into ours. Nobody claims this is settled. The anomalies in the largest scale structure of the cosmic microwave background are real, measured, and still not fully explained by any single model, which is precisely why loop quantum cosmologists point to them at all. But the specific claim that the largest patterns visible in the oldest light in the universe might be literal fossils, physical remnants of a previous universe's final geometry, preserved across a bounce that by most other models should have erased everything, is being taken seriously enough to test against incoming data from current and future CMB missions. If that turns out to be right, the biggest picture the sky can show us was never just a picture of the beginning. Somewhere in that oldest light is the shape of the universe that came immediately before this one, still legible, if you know exactly how to read it. But a bounce implies one universe hitting a floor and rebounding alone. Some physicists don't think we bounced off a floor at all. They think we were hit by something else entirely. Number 6. The ekpyrotic universe. You are floating in a dimension you cannot perceive from inside your own universe, watching two vast, flat membranes drift toward each other across an empty gap, each one carrying an entire three-dimensional cosmos on its surface like a picture printed on a sheet. They are going to touch. When they do, from inside either sheet, it will look exactly like a Big Bang. This is the ekpyrotic model, developed by physicists Paul Steinhardt at Princeton and Neil Turok, working across Princeton, Cambridge, and the Perimeter Institute. It grows directly out of string theory and its close cousin, M-theory, both of which require extra spatial dimensions beyond the three we can walk through, dimensions curled up too small to detect directly, or, in this model, large enough to hold entire universes. In some versions of this framework, our entire observable universe, every galaxy, every star, everything you have ever seen, could be confined to a single brain, a multidimensional membrane with only slightly fewer dimensions than the bulk space it floats within, alongside at least one other brain, invisible to us, separated by a gap in a direction we have no sense organ for. The ekpyrotic proposal, its name comes from the Greek word for conflagration, for a world consumed and remade by fire, is that two of these brains periodically drift together, collide, and separate, and that each collision releases enough energy, in a form indistinguishable from a Big Bang, to reheat and repopulate an entire universe. From inside either brain, the collision isn't the start of everything from nothing. It's the latest impact in a cycle that could already be unimaginably ancient, and that will happen again. Here's where it gets strange. This model isn't a fringe patch bolted onto string theory to make it sound more dramatic. It was built specifically to solve real, long-standing problems in cosmology, why the universe is so close to geometrically flat, why regions of the sky that could never have been in contact still have almost identical temperatures, without requiring the standard fix, a sudden period of cosmic inflation, at all. Steinhardt was one of inflation's own original architects, decades earlier, before concluding the collision model explained the same evidence more cleanly. And the model makes a prediction current instruments are built to test. If two brains collided to produce our Big Bang, that collision should have generated gravitational waves with a specific, distinct spectrum, different from the spectrum predicted by standard inflation. Detectors built to catch the ripples from merging black holes and neutron stars are, in principle, listening for exactly this kind of signal, a wave that isn't the echo of two stars dying nearby, but the echo of two entire worlds meeting each other at the start of time. If the ekpyrotic model is correct, the detectors searching the sky right now for gravitational waves from stellar collisions could eventually catch something else entirely, the reverberation of the actual impact that built the universe you're standing in, replaying at a frequency we're only now capable of hearing. Every theory so far, the black hole womb, the mirror twin, the fluctuating brain, the scarred eon, the remembering bounce, the colliding brains, still assumes there was a before sitting out there to be discovered, if only we built the right instrument. The next theories argue that assumption itself might be the actual mistake. Number 7. The no-boundary proposal. You ask what happened before the Big Bang, and a physicist tells you the question is grammatically perfect and physically empty, the same way it's grammatically perfect and physically empty to ask what's north of the North Pole. Not unanswered. Unanswerable, because the direction you're asking about stops existing at exactly the point you're asking about it. In 1983, physicists James Hartle and Stephen Hawking, working between the University of California, Santa Barbara, and Cambridge, published the no-boundary proposal, a description of the universe's origin built on a mathematical tool called imaginary time. In ordinary physics, time and space behave completely differently. Time has a direction, space doesn't. Hartle and Hawking's equations showed that if you rotate the time dimension using imaginary numbers as you approach the Big Bang, time starts behaving like another spatial dimension instead, curving smoothly, the way the surface of a sphere curves smoothly, with no edge, no sharp cutoff, no boundary anywhere. Picture the surface of the Earth. You can walk in any direction for as long as you like and never once fall off an edge, because the surface curves back on itself instead of stopping anywhere. Hartle and Hawking's proposal is that spacetime, near its origin, does something mathematically equivalent to that curve. Time doesn't hit a wall at the Big Bang the way a road hits a barrier. It curves smoothly into a fourth spatial-like direction, with no seam, no crack, and no starting line anywhere along it, the same way the North Pole isn't a torn edge in the Earth's surface, a place where the ground simply stops. It's just a point where the ordinary lines of longitude, our usual method for dividing up direction and giving it a name, stop being a useful way to describe where you are. Here's where it gets strange, and it's a different kind of strange than every theory before it. This isn't a claim that something specific existed before the Big Bang. It's not a bounce, not a collision, not a parent universe. It's the claim that the entire question, what came before, was built out of an assumption that stops applying exactly at the point you're asking it. The question isn't wrong. It's a category error, the same category error as demanding directions to whatever lies north of the northernmost point on Earth. The no-boundary proposal, published as The Wave Function of the Universe in Physical Review D, remains one of the most cited papers in quantum cosmology, and Hawking returned to and refined it for the rest of his career, including work shortly before his death, arguing the proposal implies a finite, comprehensible universe rather than an infinite one. Sit with that for a second, because it's a genuinely uncomfortable kind of answer. Most mysteries promise a solution eventually, a fact waiting at the bottom, if you dig deep enough or build a strong enough telescope. This one doesn't offer a fact. It offers the dissolution of the question itself, and asks you to accept that some things you assumed were open problems were actually just malformed sentences wearing the shape of a question. If before can be erased this cleanly, as a category error rather than an unsolved case, the next theory pushes further still. It asks what nothing itself is actually made of, and whether nothing too has been asking us a malformed question all along. Number 8. Quantum tunneling from nothing. You are asked to picture nothing, and you picture empty space, black, silent, cold. Stop. Empty space is not nothing. Empty space has volume, has geometry, has quantum fields sitting in their lowest energy state, ready to fluctuate. Physicist Alexander Vilenkin, at Tufts University, built a proposal around a nothing far more absolute than that. No space, no time, no geometry, no volume to be empty inside of. And he wrote down an equation for it. Vilenkin's papers, published beginning in the early 1980s and expanded in his own writings since, including his book, Many Worlds in One, describe the origin of the universe as a quantum tunneling event. Quantum tunneling is not exotic or purely theoretical, it's measured constantly in ordinary laboratory devices. From the scanning tunneling microscope to components inside your own phone. It's the same mechanism that lets a particle pass through an energy barrier. It classically shouldn't have enough energy to cross, disappearing on one side and appearing on the other, with no path in between that classical physics could ever describe or plot on a graph. Vilenkin's proposal applies that exact mechanism to the birth of space-time itself. On one side of the barrier, literal nothing, no dimensions of any kind, nowhere for a path to even exist. On the other side, a tiny, closed universe, carrying a positive cosmological constant, already expanding. The universe in this model didn't emerge from nothing the way a rabbit emerges from an empty hat, through some hidden trick. It tunneled, the way a particle tunnels, following the Schrödinger equation applied to a geometry of zero radius, a state with no size, no duration, and no location for size or duration to exist inside of. Here's where it gets strange. If nothing can be described by a wave function, if nothing has an equation that predicts what it does next, then nothing was never actually nothing in the ordinary sense of the word. It was a well-defined physical state with its own internal rules specific enough to make a real, falsifiable prediction, a strong likelihood that the young universe underwent an early period of rapid expansion, which is exactly the kind of signature cosmologists have spent decades searching for in the cosmic microwave background. Vilenkin himself, in his own writing, doesn't claim the mystery ends here. He's been direct that the model explains how a universe could tunnel from nothing, but it doesn't explain why the specific quantum rules governing that nothing existed in the first place, why there was a Schrödinger equation available to be obeyed by a state with no space or time for it to operate in. He calls this the deepest unresolved question in the proposal, not a defect to be embarrassed by, an honest edge to the explanation. If nothing had to already contain a working equation before anything existed to run it, then nothing was never actually empty. It was already structured, already rule-bound, already, in some sense that has no comfortable English word, occupied. Every theory so far assumed time was flowing somewhere, even in a state before the Big Bang, even in a state of nothing with an equation. The next theory removes the flow entirely, not before the universe. Always. Number 9. Barber's timeless physics. You have never actually experienced time passing. You have only ever experienced a single, static, complete configuration of the universe, one frozen instant containing everything, including your memory of what you believe came before it. That memory isn't evidence of a journey. It's just part of the furniture of this one frozen instant, sitting there fully formed, with no motion required to explain it. This is the argument of physicist Julian Barber, laid out in his 1999 book, The End of Time, and developed further in later research, including work with Flavio Mercati and Tim Koslowski conducted in collaboration with the Perimeter Institute. Barber has spent most of his career working independently, outside conventional university employment, in rural Oxfordshire, developing physics from first principles rather than inherited assumption, rooted in Ernst Mach's old, radical idea that motion and time only mean anything in relation to other objects, never on their own. Barber's proposal is that time, understood as a flowing river carrying events from past to future, does not exist in physics at all. What exists instead is something he calls Platonia, an unimaginably vast, timeless landscape containing every possible configuration the contents of the universe could ever take, every possible arrangement of every particle, frozen, complete, and independent, what he calls a now. There is no motion between these configurations. There is no clock ticking underneath them, connecting one to the next. There are simply an infinite number of complete, static instants, each containing its own internally consistent set of memories and physical records. Here's where it gets strange. If Barber is right, the sensation that you are moving through time, that this sentence follows the one before it, that your childhood led step by step to this exact moment, isn't a perception of actual motion at all. It's closer to what happens when a stack of still photographs is projected one after another, quickly enough to look like motion in a film reel, except in Barber's picture, there's no projector, no frame rate, and no film strip physically connecting one now to the next. Each now simply exists, complete and self-contained, containing, among its other furniture, a brain fully convinced it remembers a past that led here. Barber's more recent work identifies our own universe's Big Bang configuration as what he calls a Janus point, an exceptionally special, almost uniquely ordered now, from which entropy increases in both directions equally. Not because time flowed forward from it in one direction and could have flowed backward in the other, but because before and after were never anything more than labels for whichever direction of increasing disorder you happen to be standing inside of, looking out. If Barber is right, there is no before the Big Bang to go looking for, not because it's hidden, not because it's a mirror, not because it's sealed behind an event horizon, but because there was never a timeline underneath any of this for a canon. Before to sit on in the first place. 9 theories now, from a black hole womb to a landscape with no clock at all, and every one of them either doesn't require a before or refuses to say plainly what filled it. But long before any of these physicists picked up a pencil, other people already stood at the edge of this same question, and they didn't need equations to describe what they found there. Number 10. The cross-cultural void. You are standing among texts that have no business agreeing with each other. Separated by oceans, by thousands of miles, by centuries, by languages with no shared root and no documented contact. And laid side by side, they are describing with unsettling precision the exact same thing modern physics keeps circling back to without ever quite landing on it. In Egyptian cosmology, before creation, there is none, an infinite, dark, undifferentiated water, not empty, not lifeless, but formless, containing the potential for gods who do not yet exist within it. In Hesiod's Theogony, the founding text of Greek cosmology written around the 8th century BC, the very first thing that exists is not a god or a landscape. It's chaos, and the original Greek word doesn't mean disorder. It means a yawning gap, a vast open space, existing before Gaia, before the sky, before anything with shape. In the Norse prose Edda, compiled by Snorri Sturluson in the 13th century, the universe begins with Jananga Gap, the yawning void, a formless emptiness stretched between a realm of fire and a realm of ice, present before the earth, before the gods, before time had anything to measure. In the Jewish mystical tradition of Kabbalah, the 16th century teacher Isaac Luria described Ein Sof, the infinite, unknowable aspect of the divine that precedes creation entirely, and the concept of Tzimtzum, a deliberate contraction, the infinite withdrawing from itself to leave a conceptual space in which a finite universe could exist at all. In Taoist cosmology, texts including the Huinanzi describe Wuji, the boundless and formless state, without polarity, without division, that precedes Taji, the first division into yin and yang, the first moment anything like two could exist instead of one undivided whole. Here's where it gets strange. None of these traditions describe simple emptiness, nothing in the sense of a blank, an absence, a zero. Every single one of them describes a formless, undifferentiated, boundless potential, something that isn't nothing, but isn't yet anything specific either, existing prior to the first division, the first differentiation, the first instant anything could be measured or named. That is a remarkably specific shape for unconnected civilizations to arrive at independently, with no shared texts and no shared language. And it is, arguably, the exact shape modern physics keeps arriving at from a completely different direction. Vilenkin's nothing, which turns out to already contain a working equation. Barber's Platonia, a landscape prior to any division into before and after. Penrose's eon boundary, where an ending and a beginning become mathematically identical. Every one of them describes a boundary condition that isn't absence, and isn't yet a thing, a threshold that resists being described directly, and gets described instead as a mirror, a womb, a void, or a gap. 9 theories built from equations, and a 10th built from 3,000 years of independent human testimony, all describing the same unsettling shape at the edge of everything. Whether that convergence is coincidence, shared human intuition, or something these traditions and these physicists are both circling without fully seeing it, remains completely open. What existed before time keeps refusing to answer directly. It answers as a mirror, a womb, a scar, a bounce, a collision, an erased question, an equation inside of nothing, a landscape with no clock, and a yawning gap that people described in stone and scripture long before anyone had the mathematics to write it down properly. If you want to keep circling that edge with us, subscribe. Tell us in the comments which of these 10 theories unsettled you the most, and let us know where you're watching from.